Welcome, everyone. I'll be presenting on exploring 311 data using open source mapping, presented by myself. So, a little about me. I recently graduated Columbia with my Earth and Environmental Engineering Master's. This is where I built my foundation in GIS and remote sensing, using these tools in combination with my knowledge of hydrology and aviation. I'm currently based in Florida, but I've lived in New York City and Washington, D.C. I took part in this project to expand my technical skills into interactive mapping, combining geospatial analysis with web based visualization. So, an overview of this project. Um, it's my goal to visualize live data points of 311 information from NYC Open Data for NYC Department of Transportation service requests. Visualization matters for supporting decision-making processes by quickly identifying hotspots and complaint patterns. So this is my challenge and goal. NYC Open Data APIs use Socratic query language, which is similar to SQL, and this allows developers to query datasets. However, all NYC APIs have a limit of 1,000 rows of data. So this makes fetching and displaying large datasets a challenge. Tyler Technologies, the vendor behind NYC Open Data, suggests the offset parameter and the limit parameter. So it's my challenge to implement a solution to bypass the 1,000 row limit and efficiently load large data sets for better visualization. This is my technology stack. All of the backend is handled by NYC Open Data. I use their generated API, and the data set is called 311 service requests from 2010 to present. My front end involves JavaScript, CSS, and HTML. And with my full stack, you can see specific libraries I use, such as Select2, jQuery, OpenLayers for mapping, which is important. I also use my Google Browser dev tools and Visual Studio Code, which is built in with all Mac computers. I divided this project into 4 stages. So this is my workflow. I started with map features, data handling, a stage I like to call Does It Work, and clean and package. So map features. Map features that help with visualization would be polygon selection, base map options, filters, and zoom-based clustering. And on the right, you can see some of those filters. A challenge that I came across is with zoom-based clustering on a unified vector source. So having all these different ideas, I needed to implement them all together onto one data source. So what I did that solved that was the code on the right there, having a unified data source for all the vectors for everything. The next stage is called data handling. So my map uses viewport-based loading to fetch only what's visible, keeping it efficient. Clustering helps to manage the density, plus the data updates live. And on the right, you can see an example of this clustering with the zoom level. So the big challenge of this is the 1,000 row API limit. And a way to go around that is to get multiple requests with limit and offset. A small example is shown on the right using async function to fetch data with an offset limit of 1,000. This is a big stage with so many ideas that I want to implement, as I mentioned. I need to make sure that they all work together. This means testing live data loading, providing fallback messages, and trying to make sure that filters work seamlessly. And finally, with an interactive map, it's important to learn about cleaning and packaging. I made efforts to test my map in various browsers, Google or Explorer, and learning about deployment and handoff. So now I'd like to demonstrate how I broke the 1,000 row barrier. On the left, you can see a simple fetch and display. On the right, you can see at least 10,000 data points on the map. And this is all the code that went into it. So I start with the API request, and this is all generated by NYC Open Data. The name of the data set is right here, and these are all my query parameters. I use offset 1,000 to fetch data in chunks, So fetch data offset requests 1,000 rows at a time using the limit 1,000 offset. And then offset 0 to begin fetching data from the first row. Batch size equals 1,000 to retrieve 1,000 at a time and keep fetching to keep requesting data. If it feels repetitive, it may seem that way, but batch size 1,000 and limit 1,000 do serve a similar purpose. However, I can edit batch size 1,000 instead of having to change my query every time. So I fetch 5 batches at a time, then adding it to the map to reduce the time waiting for a large data set, or else it will keep going up to maybe 1,000,000 until you get dots on the map. Promise all requests, ensure that all 5 requests run in parallel, and wait until they're completed. And now this is what adds the current batch to the map. For purposes today, I chose 10,000 points, and this is all optional. You can change this as you wish. I added a short 100 millisecond delay between requests to avoid overwhelming the API with too many calls at once. And finally, load data is called to start fetching and displaying the data on my map. Before we get to questions, I will show you my map. You can see here from the console log how it put all of that in. So first it fetched 5,000, and from the first batch of 5,000, it only got 4,000, around 4,000 points. And then so it fetched another 5,000 up to 8,000, and it keeps going until it reaches 10,000. So it fetches another 5,000, which could have been 15,000, but instead there are actually only 12,742 points in there if you follow along. So once you reach that 10,000, then it stops. And on this map is displayed 12,742 points. Okay, now, are there any questions?
So Raquel asks, sorry for a possibly obvious question, but why is it necessary to have more than 1,000 rows? Great question. Asuka, go ahead.
Oh, well, with an interactive map, especially if you're doing geospatial analysis, if you want to find a pattern in the data, you really want as many points as possible. The basic 1,000 points that load may only be the last 1,000 from the last 2 months. Whereas if you load more than 1,000, you can get a year's worth of data. It makes for better um, patterns and analysis.
I also want to say that all data sets on open data have that 1,000 row availability. So knowing how to go past 1,000 rows is helpful, especially if you want to see more than just the latest data. Next question from Joya Debbie. She asks, what mapping library did you use for the front end? Did you find it to be flexible stylistically?
I use OpenLayers for my mapping. I really like OpenLayers, and yes, because it's so widely used, are a lot of resources that can help you customize it.
And is the dashboard only locally accessible? That's from Amtika Pi.
Locally accessible?
Meaning I have you hosted the map anywhere.
Oh, no. Right. All the code is available on GitHub, but it is not hosted anywhere.
Okay. Juan Torres asks, how long did it take your query to finish retrieving all the data from 2010?
It doesn't take to simply retrieve and display the data. It doesn't take long, maybe a minute at most. What will take a long time is if you implement filters and clusters with all of the data. Also, for this specific project, I have a time slider. It only goes from 2020 to present day. So that's what I did. I did try it once with everything, but for this purpose, I only needed around 5 years.
Someone already put it in there. Thank you. Next question from Juan Torres. How effective is this from just downloading all the data and then uploading it to your database?
You would need a lot of storage. I think working with API is great, especially if you want that live data feature. To download it, let's just say, for example, to your local computer, you would only have the last point at the time that you downloaded it. Fetching it from NYC's Open Data API is just great if you want like data the day of.
I'm going to add to that and basically say if you download all the data, even if you set up an automated download once per day, and then even if you create a database that you don't have to host in the web and you create it on your own local machine, in order to host it, you still need to then open a port to your local machine, which is dangerous. Otherwise, you need to find a way to host it somewhere that will allow you to you either need to provide some sort of software as a service, or you would need to subscribe somewhere that would allow you to host the data as well. So this is a workaround that avoids that. Now, it doesn't mean that for large compute, like if you're doing spatial analysis on the web directly in your front end, that it wouldn't be a better idea to download the data and set up a database. But this is a way to avoid that if all you want to do is display a map. Rowan asked, does the code come from the template? Is that the open layer that was referenced?
Does the code come from an OpenLayers template?
No, I think there might be. Rowan, tell me if I'm wrong. I think there might be a small misunderstanding. Open Layers is a map library that allows you to use all of its libraries for developing maps. It's all one word. So template, where in your code did you use the word template? Or does the code come from a template? Or did you start from scratch? Where did you get your code?
Oh, my code is kind of a jumble of a whole lot of different resources. I would say the best one would be OpenLayers website for some of the things that they like to do, like clustering, for example. The base of that came from what OpenLayers provides, and then you just tailor it to whatever you have. W3 Schools is also very helpful for HTML and JavaScript.
Okay. Rowan, if that's not correct, please let us know, because that's how I interpreted what you were asking. Okay, next. I'm doing a sentiment analysis using Reddit API, and they have a similar limit of 1,000 rows. Do you think your approach is replicable?
Yes, I do. That does depend on what they use to build their API. So I mentioned that Tyler Technologies is the vendor behind NYC Open Data, and they use SOQL, so CRADA. So it's important to find out what the limits of the API itself are and how it's built.
And just as a follow-up for Mika, for sentiment analysis, I'm assuming, I could be wrong, that you're using packages that do natural language processing. I don't know, because we haven't tried it yet, how this fetch would work with natural language processing. Again, you might not be doing that, so I don't know. But the fact is, in theory, it should work, but how, we don't know because we have not tested that. Again, just assuming. Okay, so Vanessa has a question. Can you explain the API further? This is specific to the 311 dataset.
My API that was generated is specific to the 311 dataset. We get a short base, and then I loaded query parameters such as Department of Transportation only, years 2020 to present only. So it is specific for this project. Does that answer the question?
Hopefully. So I have a couple of questions. Just proceeding, can you explain what is meant by Zoom-based clustering and a unified data source?
Yes, absolutely. Starting with Zoom-based clustering, I chose a Zoom level of 13. So And I will go back to that slide to help explain it. So over here on the console log, you might not be able to read the levels, but that's showing me what my current zoom level is. It can get messy if you have 10,000 or a million data points on your map. So building clusters, those circles, to try to organize it and visualize it better, that really just helps with the data handling. And once you get to a specific zoom level, you can see all the points. And then with the unified data source, so this was a problem that I had along this project. I would notice once I implemented a new feature, it would go away and some would stay. So, especially where I have a detailed layer and a clustered layer, I needed to make sure they were on the same data source so that things didn't fall on top of one another or become disabled.
So in the end, did you cluster or did you decide to use Zoom based?
There's a little combination of both. So there's both Zoom and bounding box, like wherever, at whatever extent and whatever Zoom you are, that's what you see. Clustering really only appears when you're all the way out, like zoomed out of the map. So when you first load the screen.
Can you show me?
Yes. For this is also something for like future development. I think it would be depending on how many points you have to find the perfect balance of data that you load and clusters. So for the purpose of the demonstration, I took the clustering out so that you can see 12,000 points. I can put the clusters back in, but it will take a little longer to load, longer than a minute, which wasn't ideal for demonstration purposes.
Okay, so then how do we make, because this is basically,
Are you saying a different example from this?
yeah, basically I just want you to sort it. I want to see everything in, I don't know, Queens.
Oh, okay. Okay. Understood. Well, I can filter for queens, but it won't show a huge cluster right now. I'll have to go back into
Fine.
code and comment back in the cluster feature.
Mhm.
So, Burrow, and I'll leave my console log on. You can see what it's doing. It's better to do it once this has reached 10,000. Here we have queens.
And I want to see everything in 2020 during COVID.
Okay. That is another function that I disabled for purposes of loading.
I see.
We can see right now we have 3,682 for queens, though.
Okay.
And
So if we zoom in, what happens?
let's see, zooming in on this one dot, you can still just see your dot.
So every dot is loaded. There's no clustering because it would have slowed down the functionality. Yeah. That's why that's one of the reasons this is great, but it's not perfect. So the person, I forgot the name, who mentioned that why wouldn't we just download this data and put it in a database? Yeah, the database can make it faster and it can make the clustering go more smoothly. But again, where to host it and how much does that cost? This is a workaround that eliminates that. So it's not for everything, but it is for many things.
Definitely.
Okay, so Raquel asked, Nasuka, can I ask what made you pick this as your project? Shall you tell them or shall I?
Yeah, I'd like to hear that. I think this project has evolved over time, but I think I would love to hear what you have to say as well.
Okay, so Nasuka is one of my volunteer interns. And because she was working full time and she could not become a college aide at DOT, I said, well, would you be willing to volunteer your time and still be a volunteer intern? And she said yes. And so she's doing this all on her own time while she works. And I chose the project for her. Said, hey, can you solve this problem? And she did. Okay, so Juan Torres asks, eliminates what? I think you were up. Oh, okay. Yes, I am trying to host a database in an AWS RDS with its own community. Yeah. So, Raquel, I think we're done answering your question. Basically, it was my idea, and Nasuka was a real champ in getting it done. I'm giving her a new project once this is over. And Juan is asking, what does it eliminate? So, if all you're trying to do is show clustering, this is a great method because it removes the need to limit what you're seeing on your screen. So in short, if you know that in these 5 years, you have about 15,000 points or so, and you can just basically have several different calls that grabs your data, you can show everything. It may take some time. But if what you want to do is more than that, if you want to be able to do analyses, if you want to be able to do clustering that doesn't take so long because you're waiting for every single call, then hosting a database with some sort of automated script that grabs the data from open data on a regular basis, say overnight, then that's the way to go. Then you want to do that if you're going to be doing stuff that's much more high powered. If all you want to do is display and sort like what Nasuka is doing, then it eliminates the need for having to set up a database either locally or in the cloud. That's what I meant. All right. More questions for Nasuka. I've got some seed questions while we wait for others. I don't see any right there. Seed questions for Nasuka. You might have answered all of mine, I'm not sure. Did you already go over live data loading when you were explaining the Zoom-based stuff?
I only mentioned it as something as
Okay, let's go over live data loading.
okay, sure. Specifically about it, that's a really big reason.
Start from the beginning, define it, and go for it. Yeah.
Oh, okay. Live data loading. So this is again just another important part of making sure you have the best data to use. And another big reason, as we mentioned, for using an API instead of downloading and storing on the laptop. Basically, it all comes from each time my web page refreshes, that API is calling more data each time a service request is put in. And yeah, that's like data loading. And did you mention with clustering, is that something that you
Well, I'm going to switch now to a question from Jason Howard. Are you all concerned about the number of calls to Socrata endpoints and the data transfer? This method makes things cheaper for users, but seems like it could get expensive for everyone. Are there call number or rate limits? Excellent question. Asuka?
you just have to be very specific, tell it when to put the points on the map, maybe every 5,000 like I did in the example here. Um, other than that, it's a lot of data to handle.
And Jason, just FYI, this was an experiment. It's not live. So I I'm fairly certain if this went live just like this, that there would probably be lots more bugs that we weren't aware of. So it would need a lot of user testing to make sure that this works if we're talking about larger batches of data. For example, if we did 10 years instead of 5.
Also thinking about like the bigger scheme, like since NYC has all of their endpoints, their Strata API endpoints open for anyone, like the city concerned about people just slamming the heck out those endpoints, that part seems city.
Oh,
Users managing.
I'm the wrong person to ask because I'm not with OTI's open data team. So, like I said, this is an experiment and it's not going live. But if there's anybody here from open data that says, hey, this is not a great idea to do, I'd be happy to hear it. But in theory, I don't see why making more than one call would be problematic on a small scale. Like, for example, if we limited the map to say only show 5 years at a time. So you couldn't see more than a certain amount versus show 20 years, show 30 years. Then I could see a problem. Again, I don't know the answer to your question, and I'm sorry. If there's anyone else that does, please say so in the chat or, oh, there's Oliver. Okay, if tons of people were doing it, this might become an issue. Yeah, okay. So, don't know the answer. So if Oliver says it could be an issue, but not as an individual user. So if one person is doing it locally versus a lot of people doing it, it would be a problem. Thank you, Oliver, for saving me there. I did not have an answer to that question.
No problem.
Okay. All right, let's go to Vanessa. Nsuka, could you describe a bit about the programming skills for those looking to learn more?
Ooh, I will. Before I started this project, I was mostly using Python. I was very new to JavaScript, HTML. I had a grasp of a concept of mapping though. So I would say this is a great going out and doing a project on your own is a great way to learn it. A lot of resources out there. And now I just have like supplemental knowledge that helps every other, like all my other skills in coding, really. Coding and mapping, really just a well-rounded base now.
Can you maybe, for Vanessa's benefit, list a few sources that you used to learn the skills that you needed?
Yes, I would say W3 Schools, as I mentioned, and knowing what library you're in, for example, OpenLayers was what I used for the map itself. They have their own set of tools and codes and templates that you can tinker with from there. Also, because I use Google Chrome dev tools, they have little not chat boxes, but in your console log, you'll find that they have they call them AI suggestions for any errors that you pull up. So just take the error code, um, Google it, and then search the forums, go from there. YouTube videos, and yeah, so many resources. I would say the best way that I learned was troubleshooting, was making a mistake and then figuring out what was wrong with it. That was the best that I did.
Okay, it also says, I saw that you could search by 311 service request. Could you explain that a bit?
Oh, so this is again for like future development, something that would be really cool. Sorting through all of these points. If you want to quickly type in light is a little too broad, but traffic light, then you can find all the points on the map will pop up that has to do with traffic light. Let's say in 2020. And then
So did you disable that? Can you demonstrate that?
I did disable the search part, but you can see my this gives you insight into
Mhm.
what you can search. So the data set has features called category, description, and these are most of the complaints that have to do with 311 DOT service requests, curb condition.
And also, just as an FYI, I'm not sure if everyone noticed, but before she even started, I had her limit the 311 requests to only the ones for Department of Transportation. And then she further limited it by putting a filter in for a 5-year period. So we did that to make the data sets more workable. After that, she started with the repetitive calls for 1,000 at a time. So again, 311 is a large data set. So we did what we could to make this digestible
Yeah.
for a web-based dashboard. Go ahead. I'm sorry, I interrupted you,
No,
but
great.
you were talking about the service requests. So
Mhm. So if there is, for example, something you want to search for outside of curb condition and none of these meet what you're searching for, you can always put it here. For now, this dependent drop down menu is what will suffice. This is also a cool little library that I used. The description will change depending on what you put in for complaint. So broken glass, damaged bench. Let's say bus stop shelter is not what you want. Again, you want curb condition, then you can choose from a different set of options. Broken curb.
I'm not sure if she would want to know this, but what libraries did you use to create all this great information in the side panel?
My favorite one is jQuery Select 2. So that really brings up this cool looking box right here with all the different options. Hold on, it's going to take a second to reset. Yeah, jQuery, that's a big one. It's probably the biggest one that I used. That lets you do these drop downs and multiple select. And then here you have
Oh.
both of them.
Okay, so I think we have one more. And I'm sorry, Duncan, because I think you were supposed to be reading the questions. Am I like taking work away from you? I didn't mean to.
No, not at all. It's really awesome to have you engaged, especially with your detailed knowledge of this subject matter. So please carry on.
Okay. So my last question, and again, I'm happy to forego my questions if anybody else has something, is can you go over how promise all requests work? And you're welcome, Apnika.
So promise all, that was that helped me get around sitting there and waiting for all the data to load before putting it on the map. So this is just this was really the foundation for like parallel fetching. It's very, very simple little function to put in. But basically, I can get all 5 requests, and those 5 requests being each batch that I asked for. So I asked for 5 batches of 1,000 rows at a time. And then basically, the promise all is that at a time part. Otherwise, it would just be get me 5 batches of 1,000. And then I would have to wait for each 1,000, 1,000, 1,000. So, yeah. And that,
So the idea is that promise all only displays after all of the batches have been fetched.
yes. Yeah. To put it.
And it fetches 5 batches at a time until it reaches a particular threshold.
I told it in this example to reach 10,000. So yes. But
And how did we get to 12,000? I'm curious.
oh yes. Okay. Here we are. Back at the beginning. So a first batch fetching 5,000 only pulled up around 4,000 points. And then the second batch of 5,000 added another 4,000 something points to where now we have 8,400 total. So the first 2 batches that should equal 10,000 actually pulled up less than that. So now it automatically, because it didn't reach my limit, it automatically pulls the third 5,000, which reaches 12,000. So it went,
I see.
it went 2,742 over what I asked for.
So in a way, you asked for it to pull 5,000 points at a time, 5 times, and ideally it would have done 15,000 points, but instead it stopped at 12,000 points after 5 fetches. Is that right?
After 3 fetches, yes. It's
After 3 fetches. Okay.
12, yes.
So I'm out of seed questions, and we had a bunch of questions from the peanut gallery. Sorry, for those who don't know what a peanut gallery is, I actually don't know either. My teacher used to say that. I think it was a howdy doody thing. Are there any more questions? Take it away, Nasuka.
Alrighty. I want to thank everyone for participating in Open Data Week and being here this morning. Special thanks to Magdalena Romano. She's my advisor, and you've heard from her. I really appreciate all the expertise you've brought today. If you'd like to reach out for anything, here's my email, my GitHub with this code uploaded there. It's NTW Portfolio. So thank you, everyone. Good luck. I heard some great ideas for projects out there. Good luck with it all. I hope I was able to add to something today, and thank you for having me.